Okay, so now it's time for the girder. As you know, girders are usually variable if they are roof beams, and they also have something special, the fact that they have tendons inside. So there are special cases in engineering. So aside from passive reinforcement or typical 3D reinforcement, girders will also have tendons, and we'll see during the course how we reinforce girders. I made a copy of this item. It was made of 2 polylines, and actually the reason why yesterday I could not show you how to do lines, to convert lines into polylines, was that because was due to the fact that I had 2 polylines. So we can convert polylines into lines or lines into polylines, but to convert polylines into polylines is a bit more tricky if you don't have the function. So I just right click and now we have it. So initially I had to convert those polylines into lines, and now I can combine these lines to make a polyline. And now I just have to click on where I want to continue, and that's all. Now we have a unique polyline. It was not vital for this step, but I felt I owed you an explanation of how to convert it into polylines. Now we get back to what we were doing. I will make a conversion of this item. So I'll say 2D to 3D lines. It's the same operation as before. Yes, I want a single polyline, and I'll make a copy of it. I will select this, and now it becomes 3D. You can see it here. By default, it goes exactly in 0. So this is where we have it. And I'm going to make a copy of it. Actually, I'm going to make it as a surface to see it better. So 3D surface. We can see here in the properties, we make a setting for a color for it. Okay, and I will make a copy of this initial girder. So the section that goes usually inside of a column. And now I'm going to change a bit some things. So I will change the height of this item by using the stretch entities as we did yesterday. I'm selecting the points that I want to pull, go upwards, and I'll just say 0.2. So now this is the section in the midspan. I chose randomly a size. It's 20 centimeters increase. And now we can rotate these sections to obtain the girder. So the way I'm going to do this is by going to move, to rotate, and say rotate freely in 3D. I select the first section, 90. Select the second one, 90. So now what we have here is they are just oriented in this manner. We can rotate them again 90 degrees so they will be more logically. So we can do this by going rotate. So keep in mind, first rotate and then select the items. Otherwise you can only rotate them in plane. I select, I make an axis, and again it's 90 degrees. I want to control the distance, so I will position it accordingly. I'll measure a length first. Okay, they are not, they should be also centered. So for now, with this rotation, due to the difference of height, they were now not centered, and I'll make this at 10 meters. So I just pick the point, and now okay, I will just extend it from that point 10 meters. And I'm going to make a mirror of this item. By holding here, the flyout menu appears, copy a mirror, select the surface, and use these 2 points to define the rotation axis. So this is if I want it to be symmetric. If I want it not to be symmetric, I just change the distance. Is that all for it? So from these 3D sections, to create 3D model out of them, so this variable cross section, all you need to use is this Loft function, which can be found here in the modeling Loft. And Loft is a function that interprets or interpolates in between cross sections. So it will guess a way to create the variation. I'm selecting the first section, then it says on the lower left side select second profile. Okay, he didn't like something of it. Let's see what. I think it's because they have already surfaces, and I think there were a better option with only surface. Let's try it again. Usually it works also with 3D surfaces, it's not a limitation. First profile, second one. Okay, so yeah, let's make them into 3D. Let's skip that step with the 3D option. So we will make only the 3D profile. I'll convert it into 3D again. With each version we get surprises and changes in the workflow, but it's not an issue. So we converted this into a 3D polyline, and now I'm going to copy it upwards 10 meter. I'm going to extend it with to make the variation, so it will be stretch again, and I can use the stretch in any of the view, including the isometric view, and I will add 20 centimeters to it. And now we'll make Loft, select the first profile and then the second one, and we see the result. So in some situation we need the 3D surface. In others it's just about having a profile. So actually here it says select profile, so now it would continue. So I can place the second profile as well, so that I show you how this Loft function works even afterwards. So I'll just position here 10 meters from this point. And now let's get back to the Loft function. Select the first profile, the second one, and the third one, and escape. So now we have a variable cross section. It has flanges, as we initially did. And what is interesting, okay, let's first rotate it, bring it in a more natural position. And make it concrete transparent by going to the properties and choosing the surface we already have. So once you start using surfaces in the project, you can just select through them. And now we can see better this girder. And I was talking about changes. So if you want to have this in another project where something is changing, maybe it has the opening is longer or shorter, we can easily do this by using the stretch function. And we can extend this with 2 meters, for instance. And you see it changed the slope, obviously, but it solved what we needed. And this kind of changes can be done in any plane. So if I want to shorten the other ending with 2 meter, it's no problem to do that. I'm going this direction, 2 meter. Also, the modeling is even stronger. Okay, I missed that converting to the surface, but the parasolid modeling, which is integrated in Allplan, allows you to do even more complex shape. Now it's just about showing what the software can do. It's not relevant for the precast industry. But what is absolutely interesting about this modeling is that if you delete the 3D general object, you still remain with the original items. Okay, the original items also had an initial surface there, which I did not copy. So I'll just copy the surface. So what I want to say is that aside from the 3D object, you usually get also the profile, so the intermediate profile that originate. And how can this be relevant or interesting is if you want to make different changes, you can even move this item. So I can move it like this, and the loft would still function. So it would go loft, select profile 1, profile 2, profile 3, and escape. So now it is curved because it had to interpolate through this section I just did. So again, we can start from something straight. We delete the volume that is resulting, we make some adapting to it, and we can get very spectacular results. Usually we don't play in the precast that much. The precast is more rule defined, but for other objects, as I said, Allplan is a software that can do anything. It might be really nice for architects to know that they can become more creative, and of course we can have their back covered by doing the reinforcement for complex things. So we can also do situations like this. I just rotated a bit one of the sections and see if the software can do the volume for us. So initial volumes, profile 1, profile 2, profile 3. Of course, it looks as if it's already buckled or it has a problem, but it does look nice. And what will be even nicer is how we would reinforce such a thing. It is possible, but it's not part of what we need to do today. But keep in mind the principle. So I did this modification just to illustrate how this loft works. So all the loft, this function works, are profile, which are not made of 3D surfaces, but of 3D lines, positioned so that it is plausible from geometric point of view to obtain some intersection. So now you see the intersection. So this is how I can get from profile number 1 to profile number 2 and back to profile number 1 in between. And of course, if it's about quantities, it's the same thing as yesterday, as previous example. Right click, modify attributes, and you get the quantities, area for formwork, volume, and so on. And if you want to make any changes, you delete the volume and you reposition a section. So this is an idea. It's not maybe relevant for this purpose, but keep in mind this principle, section and interpolation in between.